Hey everyone, these are the square roots and cube roots guided notes. To get started, we're going to talk a little bit about square roots. Let's say we have a square with the side length of 3 units. So let's say this square right here has a side length of 3 units. To find the area of the square, we're going to find the product of, so if we want to find the area of this, we're going to multiply 3 times 3. Another way to write this is 3 with a superscript of 2, and that means 3 squared. Notice that we are dealing with a square here. Thus, the term squared is used. Now let's say we know the area of a square is 16 units squared. To determine the area of the square, we need to determine what number squared equals 16. So if we're going backwards, we need to figure out what times what equals 16. So remember, 16 is the same as 4 times 4. Another way to write this is 4 with the superscript of 2, or 4 squared. The square root symbol looks like this. Explain what the square root symbol means. The square root symbol means the product of a number multiplied by itself is the number under the square root symbol. And then it asks, can you calculate the square root of a negative number? And remember, the square root is what number times itself equals that number under the square root. So can I multiply a number by itself and get a negative number? And the answer is no, because a positive times a positive will always equal a positive number, and a negative number times a negative number will always equal a positive number. A square has an area of 25 units squared. Explain how to determine the side length of the square. So if we know that the area is 25, then I can find the side length by taking the square root of 25. Since the square root will tell me what number times itself will equal the area. So the side length S equals the square root of 25, which equals 5. Determine the side length of a square given the area. Show your work using the square root symbol. So if the area is 100 units squared, the square root of 100 is 10. So that means the side length is 10 units. Or if the area is 49 units squared, the side length is the square root of 49, which equals 7 units. The area is 81, so the side length is the square root of 81, which is 9 units. Now we're going to look at cubes. Let's say we have a cube with a side length of 2 units. To find the volume of a cube, we will find the product of the length, which is 2, the width, which is 2, and then the height, which is 2. So remember, that's how we find the volume of a cube or a rectangular prism. We multiply the length times the width times the height. In this case, they're all 2, so we're going to multiply them all together. Another way we can write this is 2 with the superscript of a 3, and that means cubed. 2 cubed. Notice that we are dealing with cubes here, thus the term cubed. Now let's say we know the volume of a cube is 64 units cubed. To determine the volume of the cube, we need to determine what number cubed equals 64. So we need to think about what number times itself 3 times equals 64. And that's going to be 4 times 4 times 4. Because 4 times 4 is 16, times 4 is 64. So another way to write this would be 4 cubed, or 4 to the 3rd power. Okay, the cube root symbol, it is similar to the square root symbol. So we have that symbol, and then we're just going to add a little 3 right there, and that stands for cube root. And it says, explain what the cube root symbol means. And that means the product of a number multiplied by itself 3 times is the number under the cube root. Then it says, explain how the cube root is different than the square root. So the square root is a number multiplied by itself twice. The cube root is a number multiplied by itself 3 times. Then it asks me, can I calculate the cube root of a negative number? So can I multiply a number by itself 3 times to get a negative number? Well, if we think about this, if I multiply a positive number by itself 3 times, that's going to give me a positive. If I multiply a negative number by itself 3 times, so I'll have a negative times a negative times a negative, that will give me a negative number. So I can get the cube root of a negative number. A cube has a volume of 8 units cubed. Explain how to determine the side length of the cube. So I need a number multiplied by itself 3 times, that gives me 8. So I'm going to find the cube root of 8, and that is 2, because 2 times 2 times 2 will give me 8. So the side length is the cube root of 8, which equals 2. Determine the side length of a cube given the volume. Show your work using the cube root symbol. So we have the volume of a cube is 125. So I'm going to figure out the cube root of 125, and that is going to be 5 units. The cube root of 1,000, or what number times itself, equals 1,000, and that's going to be 10. Last one, the cube root of 1, meaning what times itself 3 times equals 1, and that answer is 1. Prime factorization can help you simplify square roots and cube roots. A prime number is a natural number greater than 1 with 1 and itself as the only divisors. List the first 10 prime numbers. Okay, so a prime number has to be greater than 1. So 1 is not a prime number. 2 would be 1 because its only divisors are 2 and 1. 3, 3 and 1. 4, well, that gives me 2 and 2, so no. 5 would also be prime. 6, nope, I can divide by 2. 7 is prime. 8, again, I can divide by 2, so that's not prime. 9, I can divide that by 3 and 3. 10, all my even numbers from now on are not going to be prime because they can all be divisible by 2. So not 10. 11, yes, that's only 11 and 1. 12 is even. 13, 13 and 1 is my only divisors of 13. 14, that's even. 15, can also divide that by 5 and 3, so that's not prime. 16 is even. 17, 17 and 1 are the only divisors. 18 is even. 19, yes, 19 and 1 are the only divisors. And it looks like I need 2 more. 20 is even. 21, I can also divide by 3 and 7. 22 is even. 23, yes, that's only divisible by 23 and 1. 24 is even. 25, it'd be 5 and 5. 26 is even. 27, well, that can be divisible by 9 and 3, so not prime. 28 is even. 29 is divisible by only 29 and 1. Prime factorization is when we find the factors of a number that are all prime. We're going to prime factor these following numbers down here. This may be a review for you, this may not. So if we have the 24, what times what equals 24? And we could do 6 times 4. 6 and 4, none of those are prime, so we're going to keep going. What's the factors of 6? We can go 2 times 3, and then the factors of 4 are 2 and 2. And these are all prime, so I'm going to stop. So 24 is the same as 2 times 3 times 2 times 2. Let's look at 44. We can do 11 and 4. Now 11 is prime, so we can stop there with 11. But 4 is not prime, so we're going to keep going, and that gives me 2 and 2. So 11 times 2 times 2 will give me 44. On to 80. We can do 10 and 8 will equal 80. 10 times 8 None of those are prime, so let's keep going. 10 is 5 and 2, which actually are both prime, so we'll stop there with those ones. With 80, we can do 2 and 4. 2 is prime, but not 4, so then one more with 4. That's 2 times 2. So 5 times 2 times 2 times 2 times 2 gives me 80. Now, honestly, if you can use your calculator to find the square roots and cube roots of larger numbers, the symbols will look like a square root symbol and then will look like the cube root symbol. Then that's a good way to go. However, this is a method you can use if you don't have your calculator or you are not allowed to use it on an exam. Prime factorization is helpful if you do not know the root of a number. If you are prime factoring to find the square root of a number, you will look for pairs of prime factors. For example, if you want to determine the square root of 225, you can prime factor 225, which might look like the following. So right here, this is prime factored for you. We can see it right here. Notice that there is a pair of 5s and a pair of 3s. Therefore, the square root of 225 is going to be those numbers multiplied together, 5 times 3, and that's going to give you 15. Prime factoring for cubes is very similar. If you are prime factoring to determine the cube root of a number, you will look for groups of 3 of a prime number. For example, if you want to determine the cube root of 216, you can prime factor 216, which might look like the following. So it's right here. And if it's an even number, you can always just start with 2. You don't have to if you know other factors. But 2 times 1 away, and I just kept dividing it. And then these right here are my prime factors of 216. And it says circle the groups of 3 prime numbers. So I have this group right here of 2s, and then I have this group right here of 3s. So I'm going to multiply 2 times 3 together, and that gives me 6. So the cube root of 216 is 6. Perfect squares are the squares of integers. So if I say 1 times 1 is 1, that's my first perfect square. 2 times itself, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. So these numbers right here are called perfect squares. Perfect cubes are the cubes of integers. List the first 5 perfect cubes. We have 1 times 1 times 1, which is 1. 2 times 2 times 2, so 2 times 2 is 4, times 2 is 8. 3 times 3, which is 9, times 3, which is 27. 4 times 4 is 16, times 4 again will give me 64. 5 times 5 is 25, times 5 again is 125. These numbers right here are called perfect cubes. Having knowledge about perfect squares and perfect cubes is useful in determining the square roots and cube roots of rational numbers. We want to determine the square root of 4 hundredths. We notice that 4 is a perfect square. The square root of 4 is 2. And we notice that there are 2 decimal places. Therefore, each factor will have 1 decimal place. So the square root of 4 hundredths is going to be 2/10. Now we want to determine the cube root of 1 over 27. We notice that 27 is a perfect cube. The cube root of 27 is 3, because 3 times 3 times 3 is 27. Therefore, the cube root of 1 over 27 is going to be 1/3, because 1/3 times 1/3 times 1/3 is going to give me 1 over 27. Practice. Simplify the following roots. I notice that 9 is a perfect square, so the square root of 1/9 will be 1/3. I notice right here on the square root of 25 hundredths, I notice that 25 is a perfect square, this number right there, so 5, and then there's 2 decimal places, so dividing those up between each factor is going to be 1 decimal place, so it's going to be 5/10. Square root of 136. 136 is a perfect square, so 1/6 will be the square root of it. On to cube roots. 8 is a perfect cube, so 2, and then there's 3 decimal places, so that will just give me 1 for each factor, so 2/10. Cube root of 1 over 125. 125 is a perfect cube, so 1/5. And then the cube root of 1, 1's a perfect cube. It is 1, and then 1 decimal place because there's 3 here, so divided up between each of the 3 factors will just give me 1, so 1/10. The opposite of squaring a number is calculating the square root. The opposite of cubing a number is calculating the cube root. X squared equals 81. To algebraically solve for x, we need to cancel out the squared. To do so, we will do the opposite of squaring, which is taking the square root. And that would look like this. So if I square root each side, the square root and squared will cancel. So now the equation reads x equals the square root of 81. In other words, this is asking what number multiplied by itself equals 81. Note that there are actually 2 numbers that satisfy this condition, both 9 and -9. The solutions are written as plus or minus 9. Now your teacher may just have you worry about the positive solutions, but be aware that the negatives are also a solution. And now let's look at the equation x squared equals 1/9. Solve for x by taking the square root of both sides. Now your equation is, so if I were to take the square root of both sides, this square root is going to cancel out with this square. So my equation is going to be x equals the square root of 1/9. What numbers multiplied by themselves equal 1/9? We have positive and negative 1/3. X cubed equals 8, so that's my equation. To algebraically solve for x, we need to cancel out the cubed. To do so, we will do the opposite of cubing, which is taking the cube root. And that will look like this. The cube root and cubed will cancel, so now the equation reads x equals the cube root of 8. In other words, this is asking what number multiplied by itself 3 times equals 8. The number that satisfies this condition is 2. Would -2 also work? So if I multiply -2 by itself 3 times, would that give me 8? Well, -2 times -2 is 4 times by -2 again, and that gives me -8. So no, it would not work. Explain your reasoning. The product of 3 negative numbers is also negative. The solution to the equation x cubed equals 8 is x equals 2. Now let's look at the equation y cubed equals 64 thousandths. Solve for y by taking the cube root. Now your equation is y equals the cube root of 64 thousandths. I notice that 64 is a perfect cube. 4 times 4 times 4 equals 64. And there's 1 decimal place for each factor. Therefore, y equals 4/10. Explain how you determine the cube root of 64 thousandths. Well, I noticed that the cube root of 64 is 4. Since there are 3 decimal places, then each factor will have 1 decimal place. Practice. Solve the following equations. Show you work. A squared equals 16. So if I take the square root of each side, those right there will cancel. So a equals the square root of 16. What number multiplied by itself equals 16? And that is positive 4 and negative 4. C squared equals 25 hundredths. So to figure out C, I will take the square root of each side. So that gives me C equals, I notice right here that 25 is a perfect square of 5. And there's 2 decimal places, so each one will be 1. So C equals 5/10. X squared equals 1 over 49. Take the square root of each side. Those cancel. X equals the square root of 1 over 49, which is going to be 1/7. Y squared equals 10,000. square root of each side. What times itself equals 10,000. Notice that I have 4 zeros, so they'll be divided up into both factors. So y equals 100, because 100 times 100 will give me 10,000. Oops, and going back, I forgot to put plus or minus on these. So these are plus or minus 1/7, plus or minus 5/10, and plus or minus 100. F cubed equals negative 216. I'm going to take the cube root of each side. The cube root. Now I know my answer is going to be negative, and if you don't know the factors of 216, again, I can just divide it in half. So 2, and that will be 108. And this, keep dividing in half. 2 and 54. 2 and 27. And then that gives me 9 and 3. And this gives me 3 and 3. So my factors are 2 and 3, which gives me 6. So F is going to be negative 6. H cubed equals 27 thousandths. I recognize this 27 as a perfect cube. I'm going to take the cube root of each side. Those will cancel. I get H equals 3/10. M cubed equals 1 over 1,000. Take the cube root of each side. And then I get M equals 1/10. Last question. N cubed equals 8,000. Take the cube root of each side. Those cancel. Cube root over here. I notice this 8 is a perfect cube of 2, but there's 3 zeros divided up into 3. So it'll be N equals 20. Okay, everybody, that's it for today. Thank you.